The future of artificial intelligence, the very technology that's poised to change our world, is facing a crisis? A crisis not of ideas, but of energy.
If we don't start thinking about this power problem differently now, we're never going to see this dream we have or the potential we have of this amazing technology that can truly change our lives.
One ChatGPT query takes nearly 10 times as much energy as a typical Google search, and as much energy as keeping a 5-watt LED bulb on for an hour. Generating an AI image can use as much power as charging your smartphone. Hyperscalers building data centers to accommodate AI have seen emissions skyrocket. And this problem isn't new. Estimates way back in 2019 found training one large language model produced as much CO2 as the entire lifetime of 5 gas-powered cars. And even if we can generate enough power, our aging grid is increasingly unable to handle the load.
If you look at the peak demand during the summertime, if the data center don't reduce their load, there could be a blackout.
The complex AI models we're building, the ones that can write stories, create art, and even design new medicines, are unbelievably power-hungry. We're talking about a thirst for electricity so immense that it's threatening to stall the entire AI revolution. But what if the solution wasn't to build more power plants, but to build a completely new kind of computer? A computer that doesn't think in the rigid ones and zeros of the digital age, but in the language of probability, of chance, of coin flips. This is the story of Extropic, a company that's building a computer that's not just more efficient, but might just be the key to unlocking the true potential of AI. The problem we're facing is that traditional computers are deterministic. They're built on a foundation of absolute certainty. A bit is either a 1 or a 0. There's no in between. But the AI we're building today is anything but certain. It's probabilistic. It deals with likelihoods, with guesses, with the messy, unpredictable nature of the real world. Asking a traditional computer to run a modern AI model is like trying to paint a masterpiece with a chisel. You can do it, but it's incredibly inefficient. This inefficiency translates directly into energy consumption. Massive data centers, packed with power-hungry GPUs, are working overtime to simulate the probabilistic nature of AI. It's a brute force approach, and it's simply not sustainable. So, how do we build a computer that's a natural at this?
How? How?
The answer, it turns out, is hidden in the very fabric of the universe: thermodynamics. To truly understand the revolution Extropic is spearheading, we need to take a quick trip back to the dawn of the computer age. The pioneers of computing, people like Alan Turing and John von Neumann, envisioned machines that were masters of logic. Every calculation had to be precise, repeatable, and completely predictable. This deterministic approach was a triumph of engineering, and it's the reason why the device you're watching this on works at all. But this strength has now become a weakness. The AI of today is a different beast altogether. Think about how a large language model works.
Think.
When you ask it a question, it doesn't calculate a single definitive answer. Instead, it generates a vast landscape of possible answers, each with a certain probability of being correct. It then samples from this landscape to give you the most likely response. This process of sampling is at the heart of all generative AI, and it's a process that traditional computers are fundamentally bad at. They have to use complex and energy-intensive algorithms to fake the randomness that's required. It's like trying to simulate the roll of a dice by performing a series of intricate mathematical equations. It works, but it's a colossal waste of energy. The truth is, our current approach to AI is like trying to fit a square peg in a round hole. We're forcing a probabilistic process onto deterministic hardware, and the consequences are measured in megawatts. But what if we could build a computer where the hardware itself was probabilistic? This is where Extropic's breakthrough really comes into focus. They've created a new kind of computer chip, one that's built on a foundation of what they call probabilistic bits, or p-bits. Unlike a traditional bit, which is always either a 1 or a 0, a p-bit can exist in a state of flux. It has a certain probability of being a 1 and a certain probability of being a 0. And here's the genius part. They achieve this not by fighting against the inherent randomness of the physical world, but by embracing it. At the microscopic level, the world is a chaotic and unpredictable place. Electrons are constantly jiggling and bouncing around due to thermal energy. This is the same reason why a drop of food coloring will spread out in a glass of water, or why a hot cup of coffee will eventually cool down. It's the second law of thermodynamics in action. For decades, computer engineers have been trying to suppress this randomness, to create a perfectly ordered and predictable digital world. Extropic has done the exact opposite. They've harnessed this thermodynamic noise to create a computer that's naturally probabilistic. Their p-bits are essentially tiny electronic circuits that are designed to be noisy. The random fluctuations of electrons within these circuits are what give the p-bits their probabilistic nature. It's a computer that's not just powered by electricity, but by the very laws of physics. And this has profound implications for the future of AI. So, we have these p-bits, these tiny little coin flippers. What can we do with them?
Think.
This is where the Thermodynamic Sampling Unit, or TSU, comes in. The TSU is Extropic's answer to the GPU. But instead of being designed for the matrix multiplications of deep learning, it's designed for something much more fundamental: sampling from probability distributions. Think of a probability distribution as a landscape of possibilities. Some possibilities are more likely than others, represented by the peaks and valleys of the landscape. A generative AI model's job is to explore this landscape and find the most interesting or useful locations. A GPU does this by taking a brute force approach, essentially trying to map out the entire landscape. A TSU, on the other hand, is like a skilled hiker. It can navigate the landscape with ease, finding the most promising paths and avoiding the dead ends. It does this through a process called Gibbs sampling. In simple terms, Gibbs sampling is a way of breaking down a complex, high-dimensional probability distribution into a series of much simpler, one-dimensional problems. The TSU, with its massive array of p-bits, is perfectly suited for this task. Each p-bit can be thought of as a tiny, independent sampler, and by networking them together, the TSU can explore even the most complex probability landscapes with incredible efficiency. This is a game changer for AI. But what does this mean for the AI algorithms of the future? For years, AI research has been in a kind of feedback loop with hardware development. The dominance of GPUs has led to the dominance of deep learning models, which are particularly well suited to the architecture of a GPU. This has been an incredibly fruitful partnership, but it has also stifled innovation in other areas of AI. Researchers are incentivized to create models that run well on existing hardware, rather than exploring new and potentially more powerful algorithmic paradigms. Extropic is breaking this cycle. By introducing a new type of hardware, they're opening the door to a new era of AI algorithms. These thermodynamic algorithms are designed from the ground up to take advantage of the unique capabilities of the TSU, and the results are nothing short of astounding. One of the first of these new algorithms is the denoising thermodynamic model, or DTM. The DTM is inspired by the diffusion models that have taken the world of image generation by storm. But unlike a traditional diffusion model, which has to be simulated on a GPU, the DTM can run natively on Extropic's thermodynamic hardware. The potential energy savings are almost unbelievable. Extropic claims that their approach could be up to 10,000 times more energy efficient than the current state-of-the-art. Let that sink in for a moment. That's not a 10% improvement or even a 100% improvement. It's a 1,000,000% improvement. This is the kind of leap forward that could completely redefine the economics of AI. But Extropic isn't just a research project. They're on a mission to bring this technology to the world. A revolutionary new computer chip is one thing, but getting it into the hands of developers is another. Extropic is acutely aware of this, and they've already taken significant steps to build an ecosystem around their thermodynamic hardware. Their first prototype platform, the XTR-0, is already being used by a select group of partners, including AI labs and even a weather modeling company. The XTR-0 is a hybrid system, combining Extropic's probabilistic chips with a traditional processor. This allows developers to start experimenting with thermodynamic algorithms without having to completely abandon the familiar world of traditional computing. But Extropic's ambitions go far beyond a small group of early adopters. They've also released an open-source Python library called THRML. This library allows anyone to simulate the behavior of a TSU on a conventional GPU. This is a brilliant move.
Absolutely brilliant!
It means that developers can start building and testing thermodynamic algorithms today without needing access to the physical hardware. It's a way of jump-starting the development of a new software ecosystem, so that when Extropic's hardware becomes widely available, there will be a rich library of applications ready to run on it. And that day may be coming sooner than you think. The company is already working on their next-generation chip, the Z1, which will feature 250,000 p-bits. This is the kind of scale that will be needed to run the next generation of generative AI models. We are at a crossroads in the history of artificial intelligence. The path we're currently on, the path of bigger and bigger models running on more and more powerful GPUs, is leading us towards an energy wall. But Extropic has shown us that there is another way. By embracing the inherent randomness of the physical world, they have created a new kind of computer. A computer that is not only vastly more efficient, but is also a more natural fit for the probabilistic nature of AI. The age of thermodynamic computing is just beginning, but it has the potential to be every bit as transformative as the digital revolution that preceded it. It's a future where the only limit to the power of AI is the power of our imagination.